Okay, hello guys. This is the video for chapter 6, lesson 2. In this video, we're going to talk about solving for your system of equations using substitution. So previously, we graphed our equations and found the solutions for the two systems. Remember, a system is basically when there's more than one equation, a linear equation. So far we're just looking at two equations, just two lines. What's the relationship of the two lines? Are they going to cross? Are they going to be parallel? Or are they going to overlap completely? Well, today we're not going to graph anything, but we're still going to solve for their solutions. Remember from our previous video that their solutions were ordered pairs. So there's an X, Y ordered pair as our solutions. Let's go ahead and fill out some words. See if I can just type some words out here. Okay. Let's see, substitution method. Solve one of the equations for one of the variables. Then substitute the expression for the variable into the other equation. So this is basically the steps that we're going to do today. Substitute the expression for the variable into the other equation. So we're using both. Okay. If I were you, I would copy that down. And then I'm probably going to have to take all this off because when I type it on there, I can't scroll my screen down. So now we're going to put this into practice. If we have two equations, what I'm going to do is I'm going to substitute, I'm going to replace y with what one of the equations equals, okay? Because if I know that y equals 2x plus 7 and y equals x minus 1, instead of, basically what I'm doing is I'm substituting this whole expression in place of y. So here it goes. X minus 1 equals 2x plus 7. This way, I can solve for x because I don't have any different variables. I only have one variable, which is x, so I can solve for x. I'm going to do this algebraically. I'm going to add 1 on both sides. X equals 2x plus 8. And then I'm going to subtract 2x. I have negative x equals 8. Divide by negative 1. Kind of went about this in a roundabout way. But x equals negative 8. Okay, so I've gotten x. Now you have two options. Now that I've solved for x, I can either plug x in the first equation or the second equation. And both of them should give you the same solution for y. I'm going to pick the less complicated equation, y equals x minus 1. And all I'm going to do is I'm going to replace x with 8, negative 8. So I'm going to write this as negative 8 minus 1. Negative 8 minus 1 is negative 9. So my solution for these two equations is an ordered pair, xy ordered pair of negative 8, negative 9. In other words, if I were to graph these two lines, they would intersect at negative 8 and negative 9. That's my answer. I could have used the other equation. Let's just say hypothetically, I chose the other one. I should also get -9. If I didn't, something I've done is wrong. So I'm replacing x with -8. And then you can plug this in. 2 times -8 is -16. -16 plus 7 is actually -9. So when I checked it, it did work out. Okay, problem 2. What if my equations are not in y equals mx plus b form? What if I am not able to just sub this whole thing in place of y and solve that way? Well, first step is to turn it into a y equals mx plus b form, solve for y. So this is not in the form that I would like. I'm going to rearrange it so that y is by itself. I'm going to add x on both sides. And now I have let's pause. Okay. Am I recording? Okay, what if we have an equation where they're not both equal to y? Well, if I have one equation that's equal to y, what I could do is replace this whole expression for where y is. So when I write this, I have -x plus the whole phrase of what y equals, 5x minus 5. Okay, what if I have a set of equations where they're not both equal to y? Well, if I have one equation that equals y, I could replace its whole expression for where y is. So in other words, I could write it as -x plus 3 times everything that is y in my second equation, which would be 5x minus 5. And then I'm going to write everything else down, equals 13. Now I can solve this as an algebraic equation solving for x. So I'm going to work out my distributive property first. 3 times 15 is positive 15. 3 times -5 is -15. I'm going to work this out. -x plus 15x is 14x. If I add 15 on both sides, that will be 28. Divide by 14, x equals 2. Okay, so I've solved for x. Now the other work that I have to do is just replace 2 for x in one of my equations. I think I'm going to do this one where it's solving for y equals 5x minus 5. I'm going to replace x with 2. Now I have 10 minus 2, which is just 5. So my solution is 2, 5. 2 from the x, 5 from the y. What if you have two sets of equations where neither of them equal y, and both of them are an expression equaling a number? What should we do? Well, as long as we can set one equal to y, we can use the same method we did earlier. So I'm going to solve for y with this one because as I'm looking ahead, and do that in pink, I can just add 3x on both sides and then y is by itself. So if I add 3x on both sides, I'm going to write this as y equals 3x minus 13. So I've rearranged my pink equation in a y equals mx plus b form. And then I can just replace this equation with y, what I solved for y. So this is going to be 4x plus 5 times parentheses 3x minus 13 equals 11. Now I'm going to do the same thing I did above. I'm going to distribute. 5 times 3 is 15x. 5 times negative 13 is negative 65. I'm going to keep working. 4x plus 15x is 19x. Add 65 on both sides. 11 plus 65 is 76. Divide by 19 on both sides. And x equals 4, if you plug that in. X equals 4. Okay, we've only done one part of our solution. We've solved for x. The second part is to sub 4 in place of x and figure out what y is. So you can plug it into either equation. You could even plug it in to the equation I previously reoriented here. So, I mean, you could do it multiple ways. You have 3 different options, right? Like you could plug x into this one, you could plug x into this one, or you could plug x into this one. I'm going to do this one because it's already set up as y equals a value. So I'm going to write this as 3 times 4 minus 13. 3 times 4 is 12. 12 minus 13 is negative 1. So x equals negative 1. If I wanted to plug it into another equation, I should also get y equals negative 1 for any of these two. But my solution is 4, negative 1. Okay. What if we have a system of equations with many or no solutions? So when we just look at this first glance, it's really hard to tell if this is a parallel line or an equation with no solutions, or if it's the exact same equation. So we could reorient them and make them both as y equals mx plus b format and be able to tell that way, because in our previous lesson, we studied basically how the line is drawn and what type of equations we see tells us what type of solutions we have. Or we can just plug it in. So I'm going to solve this algebraically and plug what y equals in place of y. So I have 2x minus this whole phrase of 2x minus 3. Now, it's really important that when you're subtracting, imagine y equals like a number, like 4. Then you would have 2x minus 4. Well, in this case, it's not just one number. It's actually a whole expression. And so when we're subtracting it, we're subtracting everything in that expression. We're not just subtracting 2x only, but we're actually subtracting 2x and negative 3. So we have to put the whole thing in parentheses, which means when I look at this, I'm distributing a negative 1 times everything inside. So I have 2x minus 2x, and then negative 1 times negative 3 is positive 3. So it's 2x minus 2x plus 3 equals 8. Now, these negatives and this distributing, that could get you. And so another way to just double check to see if you're doing the right thing is maybe write them as y equals mx plus b and see what type of line you have. But when I do this, I notice my 2x minus 2x they all go away. And I'm left with 3 equals 8. And if we've done this algebraically, we've learned that when two values are not actually equal, but set up as equal in our solutions, this is what we call a false statement. And anytime you see a false statement, it's a no solution. Okay. Let's look at the second one here. The same issue arises where I don't have an equation that equals y or equals x. So I'm going to reorient my equation to solve for x or y. Okay. So let's pick this one. Let's do 4x minus 3y equals 1. And I'm going to do something a little bit different in this problem where I'm actually going to solve for x and show you how to work this out if you were to solve for x, because you can actually do it vice versa. Like if you wanted to set up your equation solving for x and then plug the x value in place of the other equation, you could do that as well. So I'm going to show you what that would look like. I'm going to add 3y on both sides so that the goal is to solve for x, right? So it's 4x equals 1 plus 3y. Then I'm going to divide everything by 4. And what I have left is x equals 1/4 plus 3/4 y. Okay, not a pretty number. But since I have solved for x in my second equation that I haven't touched yet, I'm going to replace x with this phrase that I just wrote down. So I'm going to write this as 6y minus 8 times 1/4 plus 3/4 x equals -2. So when I distribute, this is not x, this is a y right here. Change this. See, this is a y. I'm so used to writing x's. This is a y. So basically, when you're looking at your equation, you have a y, just y's showing up in your equation. You're solving for y. And so I'm going to distribute -8 times 1/4 is 2, -2. And then -8 times 3/4, let's say 8 times 3/4, this cancels. 2 times 3 is 6. So this is -6y equals -2. Okay, when I work this out, the 6y minus 6y cancels, and I'm left with -2 equals -2. Whenever you have something that is a true statement, so even though your y's cancel out, this is true, -2 does in fact equal -2. This is what we call all real solutions. So you can also set these equations up where they both equal y, right, as y equals mx plus b form. And you'll see that they are actually the exact same line versus example A here. If you set it up as y equals mx plus b form, they have the same slope, but different y-intercepts, which means this is actually a parallel line, and this is actually a same line. And so you can kind of connect these concepts to the graphing because they are interchangeable, right? It's talking about the same thing, just solving it in different ways. Okay, last problem, using a system of equations. So in a talent show of singing comedy acts are 5 minutes long and comedy acts are 3 minutes long. The show has 12 acts and lasts 50 minutes. How many singing acts and how many comedy acts are in the show? So in other words, we have 5 minutes for singing and 3 minutes for comedy. And the whole show lasts 50 minutes. And I know that with my singing and with my comedy shows combined, there are 12 total acts. So basically I have 2 separate equations. One equation is really calculating the time, and the other equation is calculating the amount of acts that there are. But I'm still talking about the same thing. So I'm solving 2 separate equations, but the S and the C, the singing and the comedy, should be the same, right? It's the same show. I just have 2 different topics I'm discussing. So I wrote S and C here because one represents singing, one represents comedy. So I use those letters to kind of represent it. You can either interchange these as X and Y, but I'm not graphing anything, so really I don't have to worry too much about that. I'm going to use the method I just did above and solve for my S and solve for my C. So over here, I'm going to rearrange this a little bit where maybe if I subtract S on both sides, then I would have C equals 12 minus S. And then I could plug that in place of my equation. So now I'm going to use this system here. 5 times S plus 3 times 12 minus S equals 50. And then I'm going to keep working. 3 times 12 is 36. 3 times negative S is negative 3S. And then I'm going to subtract 36 on both sides and get 14. And then 5 minus 3S is 2S. Divide by 2 on both sides. S equals 7. Okay, so I have 7 singing acts. And then I'm going to replace my S, 7 with S, or replace S with 7. And I'm going to use this one here because it's just less going on. And bring that over. 7 plus C equals 12. Subtract 7 on both sides. C equals 5. So in other words, I have 7 singing acts and 5 comedy acts. If you were to have to graph this, let's say, if you were to have to graph this, the only thing you would want to do different is instead of S and C, write X and Y. Pick one variable to be X, pick one variable to be Y. Then you could graph it using your X and Y axis. That's the only thing you do different. But I don't have to graph this one, so I really can leave it as S and C if I wanted to. You're doing the exact same thing you did above, it's just different letters. Okay, that's all I have for today. I will stop here. We'll see you in the next video.